Welcome to Palsa Lab, your destination for amazing discoveries in science, space, AI, and technology. It's a journey that starts right now. Let's dive in.
Imagine a telescope that doesn't just watch for Earth-like worlds. It can be repaired in space by robots and kept alive for decades. Could this be how we finally find aliens? Let's find out. Hello, welcome back. Today we're diving into one of the most exciting space projects on NASA's drawing board. A serviceable, super telescope, built to hunt habitable worlds and, possibly, extraterrestrial life. Why this matters: for decades we've launched telescopes that observe the universe and teach us how galaxies, stars, and planets form. But the next generation of telescopes is different. NASA is planning a Habitable Worlds Observatory, a powerful space telescope designed specifically to find Earth-like planets in the habitable zone and to search for signs of life. And unlike most space observatories, this one is meant to be serviced by robots. Robotic servicing. Why it's a game-changer: traditionally, when a satellite or telescope breaks, the only option is to replace it or, in rare cases, send astronauts to repair it. Sending people is expensive, risky, and logistically complex. The new plan leans heavily on robotics. Repair drones and robotic arms that can diagnose problems, swap out instruments, and restore systems without humans boarding a rocket. That has three big advantages. Longer mission life. Fixing problems in orbit extends the telescope's useful lifetime. Upgradeable science. Scientists can replace or add instruments as technology improves. Lower cost over time. Repairing is cheaper than replacing entire observatories. Where it will sit. The L2 parking spot. NASA plans to place this observatory near the Sun-Earth Lagrange Point 2, or L2, about 1.5 million kilometers from Earth. Think of Lagrange points as stable parking spots in space where gravity and orbital motion balance out. L2 is ideal because thermal environment is steady, helping sensitive instruments stay cool. A stable position reduces fuel needs and mechanical stress. The same region already hosts the James Webb Space Telescope, so we know it works well for deep space observatories. What the Habitable Worlds Observatory, HWO, will do, unlike Hubble, which focuses on visible light, and the James Webb Space Telescope, which specializes in infrared, the HWO will focus on detecting planets that are potentially Earth-like, planets that sit in the Goldilocks zone around their stars where liquid water could exist. Key science goals. Find Earth-sized planets in the habitable zone of nearby stars. Characterize planetary atmospheres for biosignatures, molecules like oxygen, ozone, methane, or combinations that may hint at life. Search directly for signs of life, not just potential habitability. Complement other observatories to build a fuller picture of exoplanets. What is the habitable Goldilocks zone? The habitable zone is the region around a star where temperatures let water exist as a liquid, not so hot it vaporizes, and not so cold it freezes. It's often called the Goldilocks zone because conditions are just right for life as we know it. Of course, habitability depends on many factors beyond distance from the star, atmosphere, geology, magnetic field, and more, but being in the habitable zone is a useful first filter when searching for Earth-like planets. How the telescope will search for planets and life. The HWO will use a combination of techniques, including direct imaging, blocking starlight to actually see faint planets nearby; spectroscopy, splitting light to identify chemical fingerprints in a planet's atmosphere; long-duration monitoring, watching planetary systems over time to detect seasonal or chemical changes that might signal life; servicing and robotic repair workflow. Simplified, here's how robotic servicing would likely work in practice. Detect and diagnose. Ground teams spot an anomaly and narrow down the fault. Capture. Robotic arms or grappling systems rendezvous with the telescope and secure it. Repair or replace. Robots swap out malfunctioning modules or install new instruments. Redeploy. The observatory returns to operational status without ever coming home. This approach has been tested in many forms, from robotic arms on the International Space Station to satellite servicing demonstrations, and the HWO designs build on those growing capabilities. How this fits with prior telescopes. We've learned important lessons from Hubble and Webb. Hubble showed the power of servicing, astronauts upgraded it multiple times, extending its life and capabilities. Webb, positioned at L2, opened the infrared universe but wasn't designed for routine servicing. HWO aims to combine the best of both worlds, the ambition and sensitivity of Webb with the maintainability that Hubble enjoyed. Other mission capabilities, including gamma-ray detection. NASA has mentioned that the HWO could include instruments sensitive to a wide range of wavelengths. That may even include gamma-ray detection capabilities. While the primary mission is exoplanet discovery and characterization, having multi-wavelength tools, from radio to infrared to gamma rays, makes the observatory more versatile and scientifically valuable. Addressing the aliens question. When people say searching for aliens, they usually mean searching for signs of life beyond Earth. HWO won't find aliens in the sense of immediate contact, but it will look for strong biosignatures in exoplanet atmospheres and search for environments where life could plausibly arise. Finding a reliable biosignature on a nearby exoplanet would be one of the most profound discoveries in human history. Why not keep the telescope in Earth orbit? Staying near Earth has advantages, but for a high-precision observatory searching faint signals next to much brighter stars, L2 is better. Earth's reflected light and thermal noise, plus interference from the Moon, would make the delicate measurements we need much harder. At L2 the environment is darker and more stable, perfect for long, sensitive observations. Potential challenges and trade-offs. No mission is without risk. Some challenges include complexity of robotic servicing. Designing reliable robots that can operate autonomously at L2 is technically demanding. Cost and schedule. Such ambitious projects require significant funding and long timelines. False positives. Interpreting biosignatures can be tricky. Geological or photochemical processes can mimic biological ones, so multiple lines of evidence will be needed. Still, the potential scientific payoff, discovering a truly Earth-like world or evidence of life, makes these risks worth tackling. Why this is exciting for the future. A serviceable Habitable Worlds Observatory changes the rules for space science. Instead of building single-use instruments that degrade until they're obsolete, we can build modular, maintainable platforms that evolve with technology. That means decades of cutting-edge science, upgrades as new detectors are invented, and an observatory that can follow up on promising finds for years or even decades. Quick example. Imagine HWO discovers a nearby Earth-sized planet with oxygen and methane in the atmosphere. That mix, if persistent and not explainable by non-biological chemistry, would be a strong candidate for biological activity. Thanks to servicing, scientists could send new instruments to investigate more deeply, test alternate hypotheses, and refine our understanding, all without launching a whole new mission. Who else is working on similar ideas? Agencies and companies around the world are thinking about serviceable satellites and robotic servicing. The US leads much of this effort, but international partners and commercial teams are active too. These developments reflect a broader shift in how we design and sustain space infrastructure. Short Q and AMP. You might face, helpful for exam style or social posts. Q. What is the main goal of the Habitable Worlds Observatory? A. To discover and characterize Earth-like planets in habitable zones and search for evidence of life. Q. Why place it at L2 instead of Earth orbit? A. L2 provides a stable, low-background environment that's ideal for sensitive astronomical observations and long mission lifetimes. Q. Will humans service it? A. The plan prioritizes robotic servicing, reducing human risk and mission cost while enabling frequent maintenance and upgrades. Final summary, concise, NASA's Habitable Worlds Observatory aims to find Earth-like planets and search for signs of life while being serviceable by robots at the L2 point. This approach promises longer missions, upgradable science, and a better chance to answer the age-old question, are we alone? One memorable takeaway: a robot-repaired telescope at L2 could be the instrument that finally gives us our first convincing evidence of life beyond Earth. Call to action: if you enjoyed this deep dive and want more space updates and explainer videos, please like, subscribe, and share. And tell me in the comments, which discovery would blow your mind? A habitable planet, a clear biosignature, or something else?